Hello class, this is a video tutorial on trigonometry. In this video we are going to be learning about the fundamental ratios of trigonometry. So in my previous video we looked at identifying from a reference angle where the opposite and adjacent are, and I've given an example here where depending on where we place the reference angle, what is considered opposite is different, and what is opposite and adjacent is different depending on where our reference angle is. However, in any, let me emphasize that, in any right angle triangle, the ratios of sine, cosine, and tangent are. And these will make much more sense later on, but this is what we need to remember to begin with. So, sine of the reference angle, or sine of any reference angle, is sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. And these match to the three fundamental ratios of trigonometry. So sine, cosine, tangent are sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. If you feel as if you're not going to remember these, there's a little memory aid that you've probably seen all over the internet. It's become almost like a meme, but now you will know where it comes from. SOH, sine opposite hypotenuse, SAW, CAH, cos adjacent hypotenuse, CA, and TOA is tan opposite adjacent, TOA, SAW, CA, TOA. You've probably seen these all over the internet now. Now, hopefully, it'll make more sense to you. So, using what we have here, I'll leave these at the top of the screen. Using what we have here, let's place these triangles into their ratios. I'm going to use these as our example. Let's begin. I always go in the order of sine, cos, and tan. And let's continue from there. So let's go with sine of this angle, because it's the angle that we've given, sine theta is equal to, what is opposite to theta? It is y. Opposite, so it's y. And what is the hypotenuse of this right angle triangle? Well, it is z. Hence, we have sine theta is equal to y divided by z, or sine theta is y over z. Let's take a look now at the cos of this angle. So cos theta is equal to, well, cos of theta is adjacent over hypotenuse. So what is adjacent to theta in this triangle here? Well, it is x. So cos theta is x over, well, we already know the hypotenuse because we have it here. It's x over z. And lastly, let's find the tan theta. Tan theta is opposite over adjacent. So in this triangle, tan theta will be opposite of y over the adjacent to theta is x. So it's y over x. Let's keep going here. In some triangles, rather than me given the sides, you are given the corners. It still doesn't change what we need to find. So in this case, sine theta is opposite, or the opposite is this side here. And this side, even though it doesn't have a label, it is the side BC. So it's going to use BC, this whole length here. BC over the hypotenuse, which is this side here. So the hypotenuse is AB. AB. Let's do the same with cos of theta. Well, cos theta is, here it is, adjacent over hypotenuse, ka. The adjacent side to this angle is this side here, which is AC. So this side is side AC over the hypotenuse. The hypotenuse is AB. And lastly, we have tan theta, which is equal to opposite over adjacent. Opposite to this side is BC over adjacent, which is AC. Okay, let's move on with two more examples. At this moment, I invite you guys to pause the video and give these a go. Even though there are numbers that have appeared suddenly, it doesn't change how we do these ratios. Okay, I'm going to unpause the video in 3, 2, 1. Let's go. Let's get rid of this bug here. Okay, so let's begin first. So let's identify our reference angle here. So we know that it's going to be sine, instead of theta, it's going to be our angle sine 32. So instead of a symbol, we now have the angle. So this value here always has to be an angle of some sort. So sine theta is opposite over hypotenuse. Opposite of this is y over the hypotenuse of this triangle. Even though I didn't seem to have write it, it should be here. I didn't write it. It's going to be y over 15. That's fine. Cos of 32 is equal to, well, cos of 32 is adjacent over hypotenuse. So it's going to be x over 15. And lastly, we have tan of 32 is equal to opposite over adjacent, which is y over x. Let's solve this last one here. Let's take a look at this one now. So we have this as our reference angle, which is 52. So we now have sine 52 is equal to opposite, which is 18, over x. We have cos of 52 is equal to adjacent over hypotenuse, so 17.3, divide by x, which is the hypotenuse. And lastly, we have tan 52, which is the opposite over adjacent. So it's going to be 18 over 17.3. I hope that gave you an insight into the fundamental ratios of trigonometry. Best of luck.